Hello everyone, it's Mr. Canfield. There, I'm enthusiastic today. Today we're going to look at trigonometric, you know what? Differentiation. Okay. There, trigonometric differentiation, also known as trig derivatives. Okay. So there are 6 trig derivatives that we're going to learn today, and they are as follows. Sine of x. So we'll say that this is f of x, and then over here we'll say f prime of x. So there's sine of x, cosine of x, tangent of x, then there's cosecant of x, secant of x, and cotangent of x. So 6 trig functions, 6 trig derivatives. So at the end of the day, you have to memorize about 3. There are basically 3 different derivatives, and I want to show you some patterns and show you some things to help you remember them. So the long and short of it is I'm going to be giving you a very brief discussion of these. There are ways to prove that all of these are true, but we are not going to be doing that today. So if you'd like a more detailed video about that, please let me know. I definitely can make one. My time is short today, so that's one reason why I'm not going to be going into as much detail as to why all these are true. But they are all true. You can take it to the bank. So let's see, the derivative of sine of x is cosine of x. The derivative of cosine of x is not sine of x, but it is negative sine of x. The derivative of tangent x is secant squared x. And I'm actually going to jump. The derivative of secant x is close to secant squared, because secant squared means secant times secant, right? Secant x is secant x tangent x. And then cosecant's derivative is negative. You know, let me do cotangent first. Cotangent is negative cosecant squared x. And cosecant's derivative is negative cosecant cotangent. So I want to draw some parallels here. The first one is that all the words that start with c, when we take their derivative, it's a negative. So that's our first one. C's turn into negatives. Our second one, so sine and cosine are easy. That's another one. But the second one that I really want to talk about is the 4 of these are really 2 derivatives, and they're all really 1 derivative. If you notice, tan x and secant x have similar looking derivatives if you think about this as secant, secant. So we have secant, secant, and here we have secant, tan. If you notice that they're paired, tangent and secant both have a secant in their derivative as the first term, or the first piece of it. The second one is its buddy. So if tangent and secant are buddied together, then tangent gets a secant and a secant. Secant gets a secant and its buddy tangent. Similarly, if we buddy together these 2, they're both starting with c, so they're both negatives, but they both get a cosecant. Well, and they're both negative too. So they'll get that, and then they get the buddy. So cosecant gets its buddy cotangent, and cotangent gets its buddy cosecant. It just so happens that instead of writing buddy like secant, secant, and cosecant, we write it as squared instead. So for me, trig derivatives are all about the buddy system. So we're going to do some problems out of the book. And again, I would love to sit down and prove all these for you. I just don't have time right now. I only have 12 more minutes until my next class comes in. So question example 1 has I parts to it. Hooray. So it says A, y is equal to 2. We're 2 sine x. I'm going to take the derivative of everything on this page. We're just doing derivatives. So if y is equal to 2 sine x, then y prime is equal to 2 times the derivative of sine x, which is cosine x. Let's look at B. B is a little different. B says y is equal to sine of 2x. I'm going to write the 2x in parentheses to help us remember. Well, if I'm trying to take y prime here, well, what's the outside thing? It's sine. So then the derivative of this is just cosine, and instead of having an x, it had a 2x in there. And then chain rule happens, and we do times the derivative of the inside, which is just 2. So a better way to write this would be 2 out front, and then cosine 2x. The parentheses, when people don't write them, the parentheses of things multiplied together here, it's implied that that's cosine of 2x, and the 2x is in parentheses. It's bad form, but it's done by a lot of people. So then example C, if we had y is equal to 2 sine 2x, remembering that the 2x is actually in parentheses here, then our y prime, well, the 2 out front just stays. Then we're taking the derivative of sine x, and we're just pretending that's sine x. So it's 2 cosine x. Oh, but it's not actually x, it's 2x. And then we got to multiply by the derivative of the inside, which is 2. And you could do times 2 on the end, or you could just, save yourself the effort and put it out front. So that's really just a 4, because 2 times 2 is 4. So let's see, example D says y is equal to sine squared x. Okay. This might be hard to see, but that's saying that it's sine of x squared. So if I'm going to appropriately apply the chain rule here, I'm thinking, oh, I have something squared. So then I do 2 times the thing to the 1. And remember that was just sine of x, it just chilled. And then we got to follow chain rule and multiply by the derivative of the inside, which is the derivative of sine, which is cosine. So if I was going to clean this up and write it less messy, I'd just say 2 sine x, cosine x. Something you may have noticed so far is we require almost no knowledge of the unit circle to do any of this, anything we've done so far. Later on, as we continue to see more examples and continue to do more problems and solve problems, we're gonna learn that unit circle knowledge and Pythagorean identity knowledge is important. But for now, you can get away with a lot and be bad at the unit circle. So let's see, sine squared of 2x. So I'm taking this derivative. Remember, we want to think about this as oh, it's something squared. So that's really what this means. They mean the same thing. So that means that y prime then is going to be equal to 2. Leave the inside alone. Remember, we don't change the inside. Then we're going to multiply by the derivative of the inside. Sine of 2x. Now we've actually done this derivative a little bit earlier, sine of 2x. We got cosine of 2x and then a 2 popped out. So it's 2 cosine 2x. So I can then multiply that by 2 cosine 2x. Key thing for us to understand here is that each time, whenever we're doing the chain rule, so this was a double chain. 2 times 2 is 4. Whenever we're doing the chain rule, we kind of want to think about whatever current derivative I'm looking at, almost like it's its own problem. Ignore everything else that we've done. We're going to be multiplying it by a new thing. So I don't need to figure out what's going to happen later or anything. Just focus on where you are now or what happened previously. We're multiplying by something new. The more we can compartmentalize with this, the happier we'll be. All right, I'm going to jump I'm going to jump to example I. Again, I'm running really low on time here, and I just wanted to get something out because I have to miss some of class today for a meeting. So if I were to do y prime here, what's the farthest outside thing we see? I see an x squared, but that's inside a cosine. So I see a cosine, but that's inside a sine. So the farthest out thing that we're dealing with is actually sine. So that means the first thing we're going to take the derivative of is sine, and we get cosine. What do we do to the inside stuff? Nothing, leave it alone. Now, I'm going to multiply by the derivative of the inside. The derivative is a cosine x squared. So which of those am I paying attention to? Well, the farthest outside thing. So I'm ignoring what I already took the derivative of, and I'm going, okay, cosine of x squared, take that derivative. The farthest outside thing here is cosine. So the derivative of that, if you remember from our chart earlier, is negative sine. So I can say negative sine, and what do I do to the inside there? Leave it the heck alone. Oh, but I had an inside, and so now I have to multiply this by the derivative of the inside and get 2x. And you may think that looks terrible. That's fair. So if I were to clean this up a little bit, we're multiplying by a negative and a 2x. So I could put a negative 2x out front and then say cosine of x squared. Sine of x squared. You could write that. That's a little bit nicer. But remember, you're allowed to leave it at that first juncture and not do anything. All right, I have time for one more. So I think I will do example 12, because that looks pretty nasty. Example 12 says f of x is equal to 4 secant 3x tangent 3x. So this is things multiplied together. And it's a constant multiplied by two things multiplied together. So the constant, we can just kind of carry through everything. So the first thing says secant 3x. So we're going to be doing product rule here. We're going to take the derivative of our first thing, leave the second thing alone, plus I'm going to take the derivative of the second thing, leave the first thing alone. So let's take this first derivative. Well, the derivative of secant, plain old secant of x, is secant tangent. So the way that that's going to look here is going to be secant 3x tangent 3x times the derivative of the inside of the original. What was the inside of that? 3x. So what's the derivative of that? Just 3. So you could put a 3 out front there. So we could get 12 out front of all this business. And there's some cleaning up we could do. But similarly over here, the derivative of tangent, ignoring the 3x, is secant squared. So we have a secant squared 3x times the derivative of the inside. Derivative of the inside is 3. I don't think that this is going to come easy to everybody. I think there's a point when it starts to unlock and become easier. This is meant to help you guys dip your toe into it, especially if I'm going to be partially absent from class today. Big deal is taking your time, working through the chains. There's more we could do to clean up here, but the key thing that I wanted us to pick up is that there are no new rules for us. There are just new derivatives that we're learning. So we're learning, now I know the derivative of secant, I know the derivative of sine. I can do all the same old rules that I've been doing, just in a new situation. So hope that helps. Talk to you soon. Bye.